So this lecture on pressure and autoregulation is part of the head injury series of lectures. So I've got a bit of maths, a bit of a formula for you. So there's three measurements that are useful for us to know here. You've got intracranial pressure, which is the pressure of the brain and contents of the skull inside your head. It's normally about 5 to 15 millimeters of mercury. We've got cerebral perfusion pressure, which is the pressure of the blood going into your brain to perfuse it. That normally sits at about 50 to 70 millimeters of mercury. We've got our mean arterial pressure, which is just the background pressure maintained by a vascular system, and that's your diastolic blood pressure plus 1/3 of your pulse pressure. Remember, pulse pressure is very simple. It's just the difference between your systolic and your diastolic. So if your blood pressure is 100 on 60, your pulse pressure is 40, because 100 minus 60 is 40. So our cerebral perfusion pressure is our mean arterial pressure minus our intracranial pressure. Now, in a normal, healthy brain, for you and me at the moment, it doesn't really matter what our blood pressure is. In a very broad range of mean arterial pressure from 50 to 150, which is a very low blood pressure or a very high blood pressure, your cerebral perfusion pressure remains exactly the same. And this function of the brain is called autoregulation. So even in low blood pressure and high blood pressure, the pressure going to the brain is the same. But this function is lost in traumatic brain injury. This is really significant because the brain still needs to be perfused. But that means it's up to you as the clinician to make sure that enough cerebral perfusion pressure is being maintained. This is where this formula comes in. So if there is a massive blood in the head, so a lesion, and so the intracranial pressure within the head starts to rise, the mean arterial pressure needs to rise by the same amount to maintain the cerebral perfusion pressure. And this is typically what we see in severely head injured patients, is their blood pressure starts to slowly rise and rise and rise, and the body is doing that to try and offset the increase in intracranial pressure so the blood can still get into the brain. So our normal cerebral perfusion pressure target, we said before, is 50 to 70 millimeters of mercury, and that stays the same in traumatic brain injury. So let's say you have a big mass of blood in your head and your intracranial pressure, which is normally 5 to 15 millimeters of mercury, is now up to 30 millimeters of mercury. What mean arterial pressure are we going to have to maintain to keep that cerebral perfusion pressure in its target range? So we know down here, we need the CPP, cerebral perfusion pressure, to be between 50 and 70. And we know that the intracranial pressure is 30. So what number do we need our MAP to be? It needs to be between 80 and 100. So the formula is mean arterial pressure minus intracranial pressure equals cerebral perfusion pressure. So 100 minus 30 is 70, 80 minus 30 is 50. So if we want to keep that range between 50 and 70 millimeters of mercury for the blood going to the brain, we need to keep the mean arterial pressure somewhere between 80 and 100 millimeters of mercury. What's that actually going to mean for a blood pressure though? Well, there's a few examples here. So a mean arterial pressure of between 80 and 100 could mean a blood pressure of 120 on 80, which gives you a MAP of 93. Could be 140 on 70, which still gives you an MAP of 93. Could be 130 on 65, which gives you an MAP of 87. So there's actually a little bit of range there. This is why it's more useful to go off mean arterial pressures, which the machine, your monitor will often give you anyway, next to the blood pressure reading, than to say, we need to keep the blood pressure above 110 systolic, because we need to know the whole picture, what's the diastolic and the systolic doing, to actually get our mean arterial pressure, which is more useful in this case. But what about these blood pressures down the bottom? So we've got a blood pressure of 110 on 60, actually falls a bit short. That only gives us a mean arterial pressure of 76. It needs to be at least 80. What about 150 on 90? That gives us a mean arterial pressure of 110. So anything outside of that range is bad for the brain. Now obviously there's not a lot we can do to bring a blood pressure down pre-hospitally, but there's plenty we can do to bring it up. Now, how do we measure intracranial pressure? Before I said for the purpose of that formula that our intracranial pressure was 30, we actually can't measure it. So our aim is just to keep the MAP around 90. because that's most likely to keep the cerebral perfusion pressure within that 50 to 70 range in the pre-hospital arena. It's guesswork, but it's educated guesswork. In hospital, they'll actually put a transducer inside the skull so they can directly measure the intracranial pressure to fine-tune that formula in ICU.